This video gives the solution for Effective Maths 2, page 179, question 9. This is the question about Sean and his dog Pythagoras. Starting at this position here, Sean and Pythagoras are walking home. Pythagoras goes twice as fast as Sean, and when he gets as far as the house, he turns back to meet Sean again. I'm going to call the first stop that Pythagoras makes P1, that's when he gets home, and Sean's position at this stage I'm going to call S1. Pythagoras has gone twice as fast as Sean, so Sean is halfway home now. Since the total distance is 2 kilometres, Sean has covered 1 kilometre in this portion of his journey and Pythagoras has covered 2. Now Pythagoras turns back to meet Sean. He's still going twice as fast as Sean. So of the remaining 1 kilometre, Sean will cover 1/3 of that kilometre and Pythagoras will cover 2/3 of that kilometre. You can think of the relationship between their distances covered as being in the ratio 1:2 if you like. And so you can see that you could get your 1/3 and your 2/3 from that ratio. Now Pythagoras turns around and runs back to the house. And of course he has to backtrack over the 2/3 of a kilometre that he just covered. Sean's going half as fast as him. So Sean is just going to cover 1/3 of a kilometre at this point. Again, once Pythagoras reaches home, he backtracks to meet Sean. I know the distance between them at this stage is 1/3 of a kilometre. And again, Pythagoras, when he's going back towards Sean, he's going to do twice the distance that Sean will. So we're thinking about this ratio 1:2 again. So Sean will go 1/3 of the distance of the 3rd kilometre. So 1/3 of 1/3 is 1/9. And Pythagoras will cover 2/3 of this 1/3 of a kilometre. So in this portion of his journey, he'll cover 2/9 of a kilometre. Let's do it one more time. So now Pythagoras runs back to the house again. Let's call that P5. That's 2/9 of a kilometre again, because he's just backtracking over the same ground he's just covered. And Sean will cover half the distance that Pythagoras covers, which will be 1/9. I could use my pattern to date to project what's going to happen in the future. To get from S1 to S2, I times by 1/3. Then I repeat S2's value at S3. To get from S3 to S4, I times by 1/3. And then I repeat S4's value at S5. So I could project that S6 would be S5 by 1/3. And I can see the same pattern occurring for Pythagoras' values. And then I have that repeat again. And it continues on indefinitely. Okay, so let's go back now and look at the question and see what they want us to figure out. So they wanted us first of all to find how far from the house they are when Pythagoras gets back to Sean for the first time. So the first time they coincide is at this position here where I've marked in P2, S2. Up to this point, I know that Sean has covered 1 kilometre getting to S1 and 1/3 of a kilometre getting to S2. So I can take those away from the total of 2 to find out how much distance is left to the house. So 2/3 of a kilometre remains till they get to the house. The second part of the question asks us to find the total distance covered by Pythagoras by the time he meets Sean for the 4th time. So let's just have a think about where Sean and Pythagoras meet for a moment. We can see from my diagram up here that they meet at P2 and they meet at P4 and they'll meet next at P6 and then P8. And P8 will be the 4th time they meet. I note the repetition in the pattern for Pythagoras. So I've got position 1 for Pythagoras, so P1, then P2 and P3 repeat. I'm going to bundle these together. P4 and P5 repeat. I'm going to bundle these together. P6 and P7 repeat. I'm going to bundle these together. P8 will be a standalone. It's not going to go with there obviously would be a P9 that would repeat, but I only want to go up as far as P8. So let me lay this out for a second. I want to treat P1 as my term 1. I'm going to treat P2 and P3 together as my term 2. And I'll total the distances involved. And I'll do the same for P4 and P5. Just to note that if I'm going to go about it this way, then P8 and P9 are bundled to make term 5, but I don't want to include that P9 as part of my calculation, so I will have to take that into account at the end to get my correct answer. Okay, so let's have a look now at this sequence, and I want to sum it up. My first term is 2, so A equals 2. Or is term 2 divided by term 1, which gives me 2/3. If you want to be 100% certain that you're doing that correctly, it probably wouldn't be any harm to actually do that division again and see if it comes out the same. But if I do it for term 3 and term 2, I'm getting a different ratio, so there's an issue here. So what I'm going to do is I'm going to hold that T1 and keep it out separate, a little bit like we did in our geometric series for our recurring decimals. So instead of starting there, I'm going to start here. So I'm going to say A is 4/3. And then I can see, okay, I'm timesing by 1/3. So my R is 1/3. And if I want to be really sure that I'm correct, let me go back up here and have a look and say, okay, the next one, which is P6 and P7, is totaling to 4 over 27. And yeah, if I times that by a third, I'll get to 4 over 27 for the next term. So that's looking good. Okay, so noting for myself that I need to put back in that T1 at the end to get my total answer, and that I only want the P8 out of the P9 and P8 bundle here, I'm going to use the sum of my geometric series on these middle three terms only. And I get a total of 52 over 27 so far, but don't forget now, I have to include that term 1 from a while ago, and I also want to include P8, so I have to add those two in. So, okay, I know what P1 is, or term 1 as I'm calling it here, it's 2. I just need to establish now what P8 is. I can do that pretty easily from the list that I have up here from before. I know my pattern is times a third each time. So P8 should be 2 over 81. And so now the total distance that Pythagoras runs will be calculated by the sum of those three terms and the 2 over 81. So I'm looking at a total of 320 over 81 kilometres. Now, the method that I've used to go about this is not the only way of doing it. You may have tried a different approach and got the same answer. As long as you're explaining your method clearly, that's absolutely fine. The only thing I would say is that they do say to use geometric series, so just be aware of that. The last part of the question asks us to use geometric series to find the total distance travelled by Pythagoras before Sean reaches the house. So we have to use geometric series. We have to work on the basis that he is doing an infinite number of repeats. So we're basically getting the finite sum of an infinite series. I'm going to bundle my terms like I did before. And I'm just going to notice though that the times where he gets to the house are the odd number values at the end here of my diagram. And because he's ending up at home on an odd number position, that means that since the odd numbers come second to my bundles, I'm not going to have this extra value at the end, excuse me, to worry about. So I'll need to possibly take into consideration my P1 as a separate value, but my bundled terms should act as a series then. Okay, so what I'm going to do first of all, is I'm going to take these positions and I'm going to rewrite them with P1 as T1, and then bundling these as term 2, term 3, term 4, and so on. Okay, so here are my distances. So put together, I've got that term 1, which is 2. That's his initial run. Then I've got term 2, term 3, and term 4. Now, again, when I inspect this, if I look up my ratios between the terms, I can see that the 2 is a little bit of a funny one. Going from 2 to 4 thirds means multiplying by 2 thirds, but the subsequent ratios are 1 third. So again, I'm going to box off that term 1, and I'm just going to keep it to the end. And I'm going to focus on summing these terms to infinity. So again, my A is 4 thirds. To go from term to term, I need to multiply by a factor of 1 third. That's my R value. And of course, my formula for the sum to infinity is A over 1 minus R. So filling in, I'm going to get 4 thirds over 1 minus 1 third. This gives me a total of 2 kilometres, but then don't forget I have to include that initial 2 kilometres that he ran as well. So the total distance covered by Pythagoras is 4 kilometres.